Introduction to Adafruit Cloud. What is Adafruit? These days, cloud services are holding greater importance. They are providing global access to the data and they render admirable results with higher speeds. To incorporate the power of cloud computing in your IoT projects, which is actually essential, there are some companies that provide you cloud computing access for free with adaptable and easy interfaces. Some of them are Adafruit, DigitalOcean, ThinkSpeak, and Ubidarts. In this course, we will be using the Adafruit Cloud, and usage of other free cloud service platforms are also very similar. This session covers the Adafruit Cloud in detail, from the creation of an account, assigning feeds for data transmission, creating interactive dashboards, and the data interpretation. All these are covered, and this is pretty similar for rest of the platforms as well. Getting started. For accessing any cloud service, you need to create an account. For creating an account in Adafruit Cloud, one should visit https://io.adafruit.com, which is the homepage of Adafruit IO. In the homepage, at the right top corner, you can find the button Get Started for free. The below figure also presents you the same snapshot. You can see that we have highlighted Get Started for free in the right corner of the image. On clicking it, it will be redirecting you to the page where you need to fill all the required information. Once the fields are filled with appropriate details, click on the Create Account tab and it will then create your account. Now come back to the home page in order to sign in into your respective account, and it's presented as a snapshot in front of you. The features of Adafruit. The account you have created is a free tier account. Hence, Adafruit restricts the number of feeds, dashboards, and the data transmission rate, etc. You can view the status of your account by clicking on the profile section and look at the current status. Adafruit also gives us the ability to present our data in an intuitive way using various different representations as shown below. All these are representations that you can select and you can make your product really intuitive. Getting started. In this step, we shall discuss the features and uses of the AIO key. AIO stands for Adafruit Input Output, and the key for controlling the input output is known as AIO key. It is a unique key which is used by the program to identify the account easily. It is a unique key which is used by the program to identify the account easily. AIO key is a prerequisite for every code, and leaving this field empty will prevent the board from uploading the data. Creation of feeds. In Adafruit Cloud, feeds play a real major role because all the data sent into the cloud will be stored under these feeds. These serve as the variables that can hold different types of data. We can send values like analog values, digital values, timestamps, latitudes and longitudes of a location, etc. The feeds can hold any type of data passed in the form of string, making us free from the data type conflicts. This is a great feature and must be appreciated. Let's see how do we create your own feed. You can go to View All option that is highlighted in front of you to see all the feeds that are created, and you can access all the feeds as well. By clicking Create a New Feed tab, you can create a new feed. In this case, feed name is given as a PIR data, as we are intended and interested to detect any motion using PIR sensor. In order to achieve this, we use a PIR sensor, which is called a passive infrared sensor, mounted inside the room. The below figures shows the fields to be entered for the creation of a new feed. The name is given as PIR data and description field is optional, but we have fed it with the information as the feed for storing the PIR data. Let's know a little bit about PIR sensor right now. PIR stands for passive infrared. This sensor is not a simple one like IR sensor. The module consists of pyroelectric sensor which generates energy when exposed to heat. When a human or animal body moves in the range of sensor, it will detect the movement because the human or animal body always emit heat energy in the form of infrared radiation. The passive sensor is a sensor which does not use any energy for detecting purposes, and it just works by detecting the energy given off by other objects. This is where the sensor gets its name as PIR, passive infrared sensor. One can understand the working through the diagram that we have presented in front of you as well for quicker reference. In this session, we are using HC-SR501 PIR sensor module. This module has a pyroelectric sensor which is enclosed inside a specially designed lens known as Fresnel lens. This lens focuses the passive infrared signals onto the pyroelectric sensor for better detection. Similar to IR sensor, PIR sensor also has VCC, ground and output pins. It also contains two potentiometers which are used for adjusting the time delay and sensitivity. Time delay ranges from 0.3 seconds to 5 minutes, whereas sensitivity can go up to 7 meters. This module also contains 3 more pins which are very important and which are used for setting up the trigger mode. The PIR sensor outputs high when detected a human being or animal movement. The first mode of operation is called single trigger or non-repeatable trigger mode. In this mode, when a sensor output is high, it remains in that state until the delay time is over. The other state is called repeatable trigger mode, and in this mode, when the sensor output is high, it remains in that state until there is a movement of a human being or an animal. The output does not depend on the delay time. The connection diagrams are well explained with a note of each pin in the figure that is presented in front of you for your better reference and understanding. We also mentioned single trigger mode and repeatable trigger mode option in front of you for the better understanding. Connections. In order to publish data to Adafruit Cloud, we need a device which reads the data from the PIR sensor and publish it. To achieve this, we need to use NodeMCU, which can connect to the internet and publish data. Initially, the sensor is set in single trigger mode. Let's make the connections between NodeMCU and PIR sensor. You can follow the table which is presented in front of you, where the NodeMCU pins to LED and PIR sensor are highlighted, which are to be interfaced. Once the connections are all done, it is time to dive into the coding, which is very interesting and easy as well. The frisking model is also presented to you to let you understand that the NodeMCU 3.3 volt pin is connected to the PIR sensor VCC. The D6 of NodeMCU is connected to the PIR sensor out. The D4 is connected to LED positive pin from NodeMCU. The ground of NodeMCU is connected to LED negative pin, and ground to PIR sensor ground is also connected. Once the connections are all done, that's all. We can now go to the coding. Publishing the PIR data. Here we will build a use case where the light gets on when there is a movement inside the room. It also uploads the data to the Adafruit Cloud so that the user can remotely know if there is any movement inside the room. For uploading the data to the Adafruit Cloud, the NodeMCU needs the two libraries which are very important. Installation of ESP8266 Wi-Fi library is shown and explained in detail in the intermediary course. The Adafruit MQTT client library is provided in the resources, and its installation is same as explained in the beginner's course. Include ESP8266 Wi-Fi.h is to be included, and it's mandatory. As we discussed, Adafruit_MQTT_client.h is important as well. These two form the basics for the entire process. Now, the PIR sensor is connected to the D6 and the LED positive pin is connected to the D4. Also, the Wi-Fi SSID, that is the Wi-Fi name and the Wi-Fi password, Adafruit username, AIO key are to be filled with appropriate details in the code. As you can see in the code, the Wi-Fi name has got Wi-Fi_SSID, where you need to replace it with your Wi-Fi connection name. The password has to be replaced with your password, and make sure that the IO_username gets the Adafruit username appropriately, and IO key is also filled correctly. The PIR sensor data is stored in the variable PIR underscore data, and initially it is set to 0, and one can see that in the code. A variable named ESP of Wi-Fi client class is going to be used. The name displayed in the key column of Adafruit feed section should be used for publishing the data. For better understanding, one should refer the figure presented in front of you. This is very important point and do not forget it. In the advanced course, we expect you to understand most of the code from the knowledge you have gained from the previous 2 courses. The beginners and the intermediary courses have taught you a lot of coding, and we are going to use the same pattern for writing the codes here. Only newly written code or any new difficult or challenging logics would be explained here in this section. PIR sensor's output is configured as input and the LED positive is configured as output. The serial of node MCU is set at 115200 baud rate. Do not forget to change the baud rate after opening the serial monitor if it is a different one. All the remaining code is similar to the one used for web page controlling action through LED, which we have discussed earlier. The only change or inclusion is the MQTT.connect, which is used for establishing a broker between Node MCU and Adafruit, as the communication between the two is done using MQTT protocol, which is Message Queue Telemetry Transport Protocol. If MQTT is connected, then the Node MCU can read or write data to the feeds. If the output of the PIR sensor is 1, then the LED gets on. If the output of the PIR sensor is 0, then the LED is off. That is, if a human or an animal is detected inside, it should get 1 and the LED should glow. If the humans or animals or no motion is not detected, then the LED is retained in off state. In that case, the output is 0. You can also customize the time for which the LED should be on depending on the requirement. At the end of the void loop, we have used a delay of 2 seconds. This is the minimum delay to be used for a free Adafruit account, and this has to be remembered. You can increase the delay but cannot decrease it below 2 seconds. It will crash or it cannot get you the data uploaded to Adafruit. Remember this is a worthy point to be noted. If the values are uploaded in the Adafruit feed, the data will be shown along with a visualization graph for increased understanding and interpretation. If the strings are uploaded to the feed, the data will be shown without a graph. You can see that no movement detected and movement detected are all printed as strings and no graph is supported in this case. Let's summarize quickly. Adafruit is introduced in this session, which has a very intuitive interface, making it easy to integrate with IoT applications. Adafruit also provides you services for commercial usages such as the businesses and standalone devices. Uploading data to Adafruit using Node MCU is very easy, and the same is described in this session. The most important things needed to upload data to Adafruit are AIO key, the username, and the name of the feed. We are going to detect the presence or intrusion of any human or animal into a specific area. For an instance, we have a room which we want to monitor for any movement of human or animal into it. We are staying at a remote place and we want to see if anybody enters our room that we are trying to monitor. We are here with a solution for it, and our product will help you in tracking the presence of human or any animal, and the movement will be updated to you through the cloud. We are using Adafruit Cloud, which will get the data clearly updated about any movement which is detected inside. Also, to understand the entire process, we have got a simple LED indicator which will be on to indicate you any movement inside. It will be off if there is no movement detected. The entire process is completed with a Node MCU, a PIR sensor, and a simple LED. We are using Adafruit Cloud for the data to be updated, and it can be monitored from any remote location. Let's go ahead with understanding how the experimental setup and things are done. You can see that the PIR sensor is interfaced with NodeMCU and an LED is also interfaced with NodeMCU. The PIR sensor is presented in front of you and the LED is going to let you know if there is a movement through burning. The LED will glow if there is a movement detected. It will be off if there is no movement detected. The PIR sensor is presented in front of you, which has got a white color cover, which is called as Fresnel lens. That is very helpful to get the focus onto the sensor which is present inside the Fresnel lens. The Fresnel lens is removed right now and you could see that there is a sensor unit there and that is called as pyroelectric sensor. The pyroelectric sensor is very helpful in detection of the movement of animal or any human and it detects the heat. When we walk into a room, there is obviously heat and that is what is detected using this pyroelectric sensor, and Fresnel lens is helpful in focusing that completely onto the pyroelectric sensor. The Fresnel lens is so important and it has to be remembered. We have got 3 pins in this PIR sensor and they are VCC, out and ground. They are to be connected to the NodeMCU and similarly LED is to be connected to NodeMCU also. We are covering it back. We are keeping it back in the same position and we are going to go with the process of analysis. Now understand one more thing. We have got something more to be understood. We have got 3 pins here and 2 other potentiometers here for us to understand. The potentiometers will be helpful in adjusting the time delay as well as sensitivity. You can tune it for adjusting the sensitivity and time delay. Now you can see that there are 3 pins available. I have removed the jumper from there and these 3 pins also play a vital role. When 1 and 2 pins are covered with the jumper, it will work on single trigger mode, and when 2 and 3 are covered, it will work on repeated trigger mode. This is very important to be understood, and the jumpers are going to be helpful in selecting the single trigger or repeated trigger mode, and that is very important to be understood as I said. That is it. We need to now go ahead with the interfacing done, and then we are going to upload the data into the cloud through running our code. It's a very simple process. Open any browser of your choice. Adafruit.io has to be typed in the Google, and the first link is your Adafruit link. Click on that. Now it is the first time for you to log in. In that case, you need to get started for free, which means you need to register. If you already have an account, you can sign in with sign in option. Now I'm going to register for the first time and let me give my name over there, Anudeep Juluru, and the email address has to be given. Please give a valid email address so that the entire process can be smooth. My mail ID has been given, and select an username which has to be given to you, and most importantly, this username must be available for you to be provided with it. If the username is not available, it will alert you and you will have to choose a different username. And select a password of your choice, and once the password is selected, you can click create account. If you already have an Adafruit account, the process is very simple. Go ahead, sign in with your username and the password. Now create account has to be clicked. Once it is all done, the world of usage is very, very simple. You can see that you have successfully created an account message is flashed over there, and the next thing to be done is to select the time zone. Yes, it's very important too. The time zone is to be selected and do not touch anything else. The rest of them, let it go default. And I am from India, so I need to select the Indian time zone. As you can see, I'm searching for it, and once selected, that's all. The time zone is all done. I'm selecting GMT plus 5:30 Kolkata, and that is it. Save settings is done and the process is over. Now we need to confirm the password for us to continue. We have selected the password already. We are confirming it right now for us to use the complete facilities of Adafruit. Account is updated completely and we are all set to use the Adafruit Cloud right now. It's very easy to use and very interesting to use as well. You can sign out by the sign out option, and we are going to re-sign in again so that we will see how smooth it is. You can see that I'm going to type my username and the password, and once it is done, the usage is going to be explained to you in terms of the data and the feed. I am logging in with the username instead of email. You can also go with email as a login option. I am signing in. Once you are done, that's it. You are taken into the cloud. This is the cloud dashboard that you are seeing, and this is very important for you to understand. And the profile will be showing you what is your status. I mean, are you using a free account or a paid account? We have 10 feeds allowed. We can have 5 dashboards. The rate is 30 per minute. We have not used anything, so it is 0 per minute showing, and the storage will be retained for 30 days. All these are the status for the free account. We have not gone for the paid version, and when you go for paid version, this will be definitely a better option. And here, since we are going for free version, we get only limited facilities available, but that is enough for learning. Next one is feed. This feed is very important, and as of now, we do not have any feed we need to create. When you click view all as I did, there will be only default feed and nothing will be available because we have not created any feed. Now when you click actions, you can create new feed, and when you click the new feed, you will be able to name it and you can give a description. I am creating a feed as PIR-data, and I can give an optional description here. You can even ignore it. Feed for storing the PIR data. I am saving it, and that's all. We have now created a feed. The feed is created less than a minute ago, and you could see that. There is no data available right now, and record 0 through 0 of 0 is present here because we have not got any data into the cloud right now. Now I clicked Adafruit IO key, which is very important, and you can see that there is a key available which we need to use. We are using Arduino board, so select and copy the IO username and IO underscore key, which is highlighted right now, and you need to use that in the code. Let us go to the code and replace these highlighted lines with the one that is copied from the Adafruit site. Now we need to update the name of our Wi-Fi connection and Wi-Fi password appropriately for us to get the compilation and data upload done into the cloud. Now we need to see if ports are all properly selected, the board is properly selected, everything is properly to be done for us to complete the process. Now I am compiling and uploading. The process may take a little while, but once it is done, it's going to be very easy for us to complete the task. Now you can see that the uploading process happens, and it may take few seconds to maximum a minute for us to complete this entire process. This is very easy, and at the same time very important to follow the steps. If you miss any of these steps, probably it could fail. Now it is 90%, 100% is done. That's all. Now you can see that the movement is going to be detected. First, the serial monitor is opened and the connections are confirmed. You can see that the IP address is presented to you. It is connected to MQTT. Uploading PIR data has come. No movement is detected right now, and light in the room is in off state, and that's what is presented to you in front of you. And the same data goes on to Adafruit as well, which we will reveal a little later. Now we are going to have some movement inside. I'm going to move my hand very close to the PIR sensor so that it detects the movement. You can see that the LED has immediately glowed and it shows that there is a movement detected, and message is also properly updated. Now I'm moving out of it and the movement is not detected message has come. When the movement is detected, the message movement detected has come and the LED was glowing. When the movement is not detected, the LED is off and no movement detected message has come. We can adjust this time frame also, as in how much time has to be the threshold for the LED to glow. Now we are getting into the PIR data. Inside that, you could see that the entire data, whatever we have received in the serial monitor, is available. The movement detected message along with no movement detected message is all highlighted and stacked one after another appropriately with time frame, and this can be watched by anybody from remote. So this is how somebody can understand if there is any intrusion into the place which they wanted to monitor. This is a very simple yet a very efficient system for somebody to track the movement.